Exercise 2.5, problem 1, 8, subdivision 1. So let's read the problem. Find the sum of the first n of the series 7 plus 77 plus 777. It goes on. N terms. We have to find the sum of n terms of this series. But if you look at it, it is not a geometric progression, but it is close to a geometric progression. 7 times 7, 11 are 77. 77 into 11 is not 777, but it is close to it. So there is something close to geometric progression. So I think we should try to convert this into a geometric progression. Identify A, R, N, and then calculate the sum of the series. Okay. Series is 7 plus 77 plus 777 is given. We need to find Sn. The formula for Sn is given here, but I don't think it will be of any use as of now, because we need to first convert this into a geometric progression. So first step is to convert the given series into a geometric series. Once that is done, identify A, R, and N and substitute those values in this equation. Sn equal to A into R to the power of n minus 1 divided by R minus 1 and calculate the sum of the series. Okay, so let's do the problem together. The given series is 7, 77, 777. You can see, 7 can be taken commonly out. So let's take 7 out. So it will become 1, this will become 11, and this will become 1, 1, 1. Okay, up to n terms. Now you multiply this and divide. Again you see 1 into 11, 11 into 11 is 121. Something is missing. But they all have 1, 10, 100 as a base. So whether we can take this 10 together, that's what we are trying to do. So multiply and divide this by 9. So it will become 7 into 9 by 9. Okay, 9 you take it inside. So and keep the denominator out, 9. So it will become 9 into 1 is 9, 99, 999. You got it? We are multiplying and dividing it by 9. So that is into 9 by 9. The bottom 9 I am carrying it here, so it becomes 7 by 9. And the numerator 9 I am taking it inside, so it becomes 9 into 1, 9 into 11, 9 into 111. Now if you see this 9 can be written as 10 minus 1. 99 can be written as 100 minus 1. 999 can be written as 100,000 minus 1. And you have like this 10 n terms. So this 7 is converted into a sum of, 10 minus 1, 100 minus 1, 1000 minus 1, etc., etc. Okay. Each one is one term. This is one term, this is one term, one term. Okay, but inside that there are two numbers there. Okay. Now, group all the 10, 100, 1000 together. So you'll get 10 plus 100, that is 10 square, plus 1000, that is 10 cube. So you will have n terms, because the pair of you have n pair of terms. So you can break it. If you break it also, you will get n individual terms. So you will get 10 plus 10 square plus 10 cube, n term. Group all the 1 together and take minus sign commonly. So minus, if you take 1 plus 1 plus 1 up to n terms, because you have the n pair of terms. Okay. Now if you see, this is a geometric progression with A as 10 and R as 10. You got it? And we don't have the value of n, but there is what you have to write to is you have to write the sum itself in terms of n and leave it there. So A equal to 10 and R equal to 10 again. But if you look at this, 1 plus 1 plus 1 n terms is what? It is the value of that is n. If you add 1 10 times, you get 10. If you add n 1 n times, you will get n. Right? So this equation can be written as 7 by 9. Okay? And you have the formula Sn equal to A into R to the power of n minus 1 divided by R minus 1. A is 10. R to the power of n, that is R is 10. So 10 to the power of n minus 1 divided by R minus 1. R is 10. So 10 minus 1 minus n. Okay. This is the formula which you are using, and you are applying it here, and this is getting added to n, and 7 by 9 is still outside the bracket. So that's what I've done here, 7 by 9 here. we applied Sn equal to a into r to the power of n minus 1 divided by r minus 1, because in our case a is 10 and r is 10, and that 1 plus 1 adds up to n terms. So it becomes this, the previous step comes to this one actually. Now if you look at this, you should be able to simplify it a little further. 7 by 9 into n is 7n by 9, and take it out of the bracket and keep the remaining inside the bracket. Okay, so this will be, now again this 10 and 9 you can multiply with by 7 by 9, so that will become 70 by 81 into 10 to the power of n minus 1 equal to, sorry, minus 7n by 9 is the sum of n terms. You got it? So this is how this problem can be worked out. So let's repeat. So what are we trying to do? We are taking 7. First, clearly we have to understand that it is not a geometric progression. We need to convert it into a geometric progression. So 7, 77, 777, you are taking 7 commonly out. It becomes 111, 111. You multiply and divide it by 9. So the denominator 9, we are bringing it out. The numerator 9, we are taking it inside. So it will become 9 into 1, 9 into 11, 9 into 111. So this becomes 999, 999. And this you can rewrite it as 9 as 10 minus 1, 99 as 100 minus 1, 999 as 1000 minus 1. And you take all these 10, 100, 1000 and group it together, and group all the minus ones together. So this becomes 10, this 100 is 10 square, 1000 is 10 cube. And minus 1, minus 1, minus 1, take the minus sign out, it will become 1, 1, 1 up to n terms, because you have n pair of terms. N pair of terms means you will have n number of this 10, 10 square, 10 cube, and you will have n minus 1s. Okay. Now you see this is a geometric progression with a equal to 10 and r equal to 10. 10 tens are 100, 100 tens are 1000. Use this formula and simplify to get the value. The key is n we don't know, so the sum will be always in terms of n. So this is a generic term for the sum. The moment you put n, if you put n equal to 10, then you will get the sum of S10. If you put n equal to 20, you will get S20. Okay, so this is a generic term of the sum, right? That's how this problem is solved. So I hope you have understood it clearly now. Please pause the video and work this problem on your own. Unless you work it out, you won't get it clear, right? Thanks for watching this video.